Hello, this video discusses learning target 2 of topic 1, and it says I can evaluate square roots of small perfect squares. So at the end of this video, as long as you take the notes that go in the packet, you can go ahead and check that box off. Let's go ahead and begin. Learning target 2 is about perfect squares. So we are going to evaluate perfect squares, but first we need to know what a perfect square is. And a perfect square is the product of an integer squared. So let's fill in those blanks there. A perfect square is the product, which means the answer to a multiplication problem, of an integer squared. And when I say integer squared, that means a number times itself. And remember, we're just talking about numbers that don't have decimals or fractions. That's what an integer is. So an example of a perfect square is 25. The reason 25 is a perfect square is because it is the product of 5 times 5, or 5 squared. Another example of a perfect square is 81. And the reason for that is that 9 times itself, 9 squared, is 81. Now hopefully you can come up with some on your own. I will do one more. A perfect square, another example, is 121, and that is because 11 times 11 is 121, so 11 squared is 121. So the numbers that I have written in black there, right here, 25, 81, and 121, are perfect squares. Now, let's talk about down here what a square root is. Using the fact that 5 squared is 25, we're going to talk about the square root. So you see that 25 is the perfect square, and when I do the square root of 25, I'm sorry, I got a little ahead of myself there. If I take the square root of 25, then I would get 5. So we say that 5 is the square root of 25. 5 is the square root of 25. And that is because 25 is equal to 5 squared. So the square root of 25 is 5. Let's talk about the number line up above. What we're going to do is we're going to write down the equivalent square roots to all of those numbers on that number line. So we said 5 was the square root of 25. The way we write a square root, you can see down below that this symbol here is the square root symbol. So where 5 is here, underneath it I'm going to write the square root of 25. Because those two are equal. Using that same thought process, we look at this example up above. 9 squared equals 81, so that means 9 is equal to the square root of 81. So we're going to add that in there. And we could also fill in the 11, because I gave you this information up here. So the square root of 121 is equal to 11. Now, I would like for us to fill in the other numbers. So what you have to think about is what each number on the number line multiplied by itself would equal. So let's start with 0, that's the easiest. 0 times itself is 0. So the square root of 0 is 0. 1 times 1 is 1, so the square root of 1 is 1. Now think to yourself, what is 2 times 2? 2 times 2 equals 4. So the square root of 4 is equal to 2. What I would like for you to do is pause this video right now and see if you can do the rest of that line without a calculator. My guess is that most of you will be able to do up through 10, and then you might struggle a little bit with the other numbers. Give it your best shot by pausing the video right now and trying to fill in those numbers. When you continue the video, the correct answers will pop up, so please check your answers. Pause the video now, please. Okay, so hopefully you followed my instructions, and now you can find out if your answers were right or not. So look at the green answers, compare them to what you wrote down, and if you got any of them wrong, please go ahead and fix them. Let's move down to the parts of a radical right now. The symbol that we call the square root is actually a radical symbol. So that's this symbol right here that I am outlining in green. It's a check mark with a bar at the top. So that is a radical symbol. You could say radical symbol or radical sign. It doesn't matter which one. So that's the radical sign or radical symbol, either one. The arrow that is pointing to the 64. So the 64 right there, I'm going to outline it in red. The 64 is called a radicand. The number under the radical sign is a radicand. And finally, it kind of looks like this last arrow is pointing here towards this symbol, but it's actually the space inside here, that there's nothing there on this one. So I'm going to put a little circle here. That's where it's pointing. And sometimes you might see a little number in there. If you don't see a number, the number is 2. It's automatically a 2. But sometimes you'll see other numbers, and those numbers are called, that is called the index. So the index of a radical is that little tiny number. If there isn't one in there, it's a 2. Otherwise, there might be a 3 or a 4. We're just going to be seeing 3s in there this year. So that's what the index is. Now, the bottom of your paper here is asking you to find each square root. You can take the easy way and refer back to the number line above and fill in the blanks, or you can challenge yourself by covering up that number line and seeing how many you can get without looking at the number line. So what I would like for you to do is finish this up on your own, pause this video, complete the table there, so the answers go in the blanks. So I'll do this as you would put the square root of 1 equals and then the answer in that box. Try that on your own. Once you're done, restart this video and check your answers. Pause now. Hopefully you followed those instructions. Check your answers, make sure all of them are right. And to be clear, these should be mental math problems that you would not need a calculator to tell me those answers. So you should be able to do all of these without a calculator. And that wraps up this lesson. This is Learning Target 2, so if you've completed these notes, go ahead and put a check mark on the front page.